So we've got an axis here. I'm going to pick some point there. I'm going to make a perpendicular line here. Alright. Now I'm going to use a compass to divide this distance evenly into pieces. And then I'm going to divide the distance vertically into pieces, like so. Now when I do that, I can make a square here and a square here. I'll then take my ruler, I'll line it up with my starting point and at my point here. I know that my x value and my y value, I've got my 0 here, and this is my 1 and my 1. So because this is going up, my values are changing the same speed. I know that this slope, that's a slope of 1. It also happens to be 45 degrees. If I go up 2 and draw my line, this line has a rise of 2 over a run of 1. So the slope is equal to 2. If I keep going up, this one I have my rise of 3 over a run of 1, gives me a slope of 3. And if I go up to 4, like so, this is a slope of 4, or 4, and it's off the screen, but I can go up to 5. Now if I keep going up like that, if I go infinitely tall, it's still going to be not quite the more rise I have compared to my run, it keeps getting steeper, but I can't get this vertical line because on this vertical line my run changes. So on vertical, my rise can be anything. My run equals 0. So the slope equals to something divided by 0, which I can't solve. That's beyond infinity. So I can't solve that one. It just doesn't exist. So I can't have a slope for vertical. That's infinitely steep. Now on the other hand, if I go over instead of up, and so, okay, let me use, just like that. Okay, so now I'm going to start here. This gives me a run of 2 and a rise of 1. So this is a half. One third. 1/4. One fifth, 1/6, and so on. So here, the closer I get to flat, the smaller the number. And ultimately, if I want a horizontal line, this is 0 divided by whatever. And so the slope of a horizontal line is just 0. And so my slope of 1 is at 45. Bigger numbers get steeper and steeper, but never quite touch vertical. Smaller numbers, fractional slopes are less than 0, ultimately getting more gradual and more gradual until ultimately they're not going up at all, and then you get a slope of 0. You can have the same thing at the bottom. So if we have our lines like so, we can get a distance sideways. So here, I have a 1 for my rise, except it's negative. It's going in the negative sideways direction. And a 1 in my over. So this has a slope of -1 going down. So if the slope goes down, it's negative. If the slope goes up, then it's positive. And these are going to be your fractional. Your fraction slopes are going to be up here. Numbers bigger than 1 over here are going to have our negative numbers. Greater or less than 1. I guess it would be, those numbers are more steep going down as opposed to the going up. So going up, going down is negative, going up is positive. I guess it would be positive sideways and negative sideways, but most mathematicians ignore that because it's tricky. Alright, so that's negative slopes.